Welcome to aminacademy.com. Let us do life stories of scientists. In that, we'll discuss about Ibn al-Haytham. Ibn al-Haytham was an early prominent of the concept that a hypothesis must be supported by experiments based on confirmable procedures or mathematical reasonings. An early pioneer in the scientific methods, 5 centuries before Renaissance scientist, he is sometimes described as the world's first true scientist. Let us discuss further about him. Ibn al-Haytham's work was remarkable for its emphasis on proof and evidence. He is known to have said, if learning the truth is the scientist's goal, then he must make himself the enemy of all that he reads. By this he meant it was essential to conduct experiments to test what is written rather than blindly accepting it as true. Ibn al-Haytham was born in the year 965 in Basra. He died in about 1040 in Cairo. He was one of the earliest scientists to study the characteristics of the light and the mechanism process of vision. He sought experimental proof of his theories and ideas during many years living in Egypt, 10 of which were spent under what we may know all protective custody, house arrest. He composed one of his most celebrated works, the Kitab al-Manazir, whose title is commonly translated into English as Book of Optics, but more properly has the broader meaning of Book of Vision. Ibn al-Haytham made significant advance in optics, mathematics, and astronomy. His work on optics was characterized by a strong emphasis on carefully designed experiments to test theories and hypotheses. In that regard, he was following a procedure somewhat similar to the one modern scientists adhere to its in their investigative research. Invention of Ibn al-Haytham. He is known for the earliest use of camera obscura and pinhole camera. As stated above, he contradicted Ptolemy's and Euclid's theory of vision that objects are seen by rays of light emanating from the eyes. According to him, the rays originate in the object of vision and not in the eye. A visionary scientist. Born in Basra, Iraq around year 1965, Al-Hasan ibn al-Haytham, Latinized as al-Hazan or al-Hazan, was a pioneering scientist thinker who, from his observation of light entering a dark room, made major breakthrough in understanding light and vision. He set a new standard in experimental science and completed his influential book of optics sometimes around 1027. He thus concluded that vision would only take place when a light ray issued from the luminous source or was reflected from such a source before it entering the eye. Ibn al-Haytham is credited with explaining the nature of light and vision through using a dark chamber he called al-Bayt al-Muslim, which has the Latin translation as the camera obscura, the device that forms the basis of photography. Out of the 96 books he is recorded to have written, only 55 are known survive. Those related to the subjects of light included the light of moon, the light of the moon, the light of the stars, the rainbow, and the halo, spherical burning mirrors, parabolic burning mirrors, the burning sphere, the shape of the eclipse, the formation of shadow, discourse on light, as well as his masterpiece Book of Optics. Invited to Invited to Egypt to help build a dam on the Nile River. From his observations, the light entering dark room, he made major breakthrough in understanding light and vision. About the lights, he invented a lot of informations. His observations led him to make significant revision to ancient views about how our eyes see. Through his studies of earlier work by Galen and others, he gave names to several parts of the eyes, such as the lens, the retina, and the cornea. He set a new standards in experimental science and completed his great book of optics sometimes around 1927. His book of optics was translated into Latin and had significant influence of many scientists of the Middle Age, Renaissance, and Enlightenment. Ibn al-Haytham was born after centuries of intense activity in mathematics, astronomy, optics, and other physical sciences. Ibn al-Haytham stands out in this long list as the leading figure in both the science of light and science of vision because his book depends so heavily on experimentally based demonstrations. His work was important for two reasons. Ibn al-Haytham used systematic experimentation in his work on optics. Ptolemy, working in the Greek-based culture of 2nd century Alexandria, had used a similar approach in his work on optics. However, Ibn al-Haytham's work was distinguishably novel. In this way, he formed part of the intellectual legacy that Latin scholars derived from Muslim civilization from the 13th century onward, including the Renaissance and early of modern periods. With new scientific insights such as those of Ibn al-Haytham, as well as medical marvels, astronomical observations, new maps, libraries, and advanced schools that taught various mathematical subjects, Muslim civilization made a significant and crucial contribution to the accumulation of scientific knowledge in the pre-modern age that changed the ancient world. These past discoveries have shaped our homes, schools, hospitals, towns, the way we trade, travel, and our understanding of the universe. The story of Ibn al-Haytham's life and discoveries is truly extraordinary. His brilliant breakthrough, however, came at a time of the darkest episode of his life. Ibn al-Haytham's scholarly reputation spread well beyond Basra. He is known to have said, "If I would be given the chance, I would implement a solution to regulate the Nile flooding." Yet, it just as life was at its bleakest moment, Ibn al-Haytham might have made the dazzling discovery for which he is best remembered. Legend says one day he saw light shining through a tiny pinhole into his darkened room, projecting an image of the world outside into the opposite wall. Ibn al-Haytham realized that he was seeing images of objects outside that were lit by the sun. From repeated experiments, he concluded that light rays travel in straight lines and that vision is accomplished when these rays pass into our eyes. Ibn al-Haytham's books of optics as well as some of his other scientific works were translated into Latin, making them available to European scientists including Roger Bacon, Johannes Kepler, and even Leonardo da Vinci. Ibn al-Haytham suggested that only the light rays that hit the surface of the eye head on would pass into the eye, creating a representation of the world. It was It was Kepler in the 16th century who corrected this and proposed that the object of sight, what, what is seen, comes from both perpendicular and angular rays that hits the eye to form an inverted image on the cornea, on the retina. Among Ibn al-Haytham's others insight was his understanding of the crucial role of visual contrast. For example, he realized the color of an object depends on the color of the surroundings, and that contrast of brightness levels explains why we can't see the stars during daytime. In search of evidence, Ibn al-Haytham studied lenses experimental with different mirrors, flat, spherical, parabolic, cylindrical, concave, and convex. His practical results were clear. Visual objects seen by us through light refractions across this thick material such as water and glass are bigger than their real size, he wrote. After his death, Ibn al-Haytham's writings were more influential in Latin than Arabic. The only significant work in Arabic that built on Ibn al-Haytham's idea was produced in the early part of the 14th century in present-day Iran by Kamal al-Din al-Farisi, who was himself a brilliant scientific thinker. When Ibn al-Haytham's book of optics was translated into Latin, it had great influence and was widely studied, read. It was published as a print edition in 1572 so that he could be made more easily available. Some questions Ibn al-Haytham raised remained unsolved for a thousand years. One such was called al-Hazan's problem, for which he offered a geometrical solution. Given a light source and a spherical mirror, find the point on the mirror where the light will be reflected to the eyes of an observer. Ibn Haytham solved this problem geometrically, but it remained unsolved using algebraic methods until it was finally solved in 1997 by the Oxford mathematician Peter M. Newman. And yet, some mysteries remains. Ibn al-Haytham affirmed that an optical illusion was the reason for the moon appearing so big when it is low in the sky close to the horizon in comparison to its size when at the zenith. And still no one knows why this happens. This and other questions in science has yet to be solved, leaving a legacy of intrigue for us to tackle today. So far, we discussed about Ibn al-Haytham, a great thinker and scientist. We have done. Please subscribe our YouTube channel.